Okay. Let's do some programming. Okay. This is just getting work done, but I will give a little intro. So I'm fixing my enums. There was a lot of missing syntax actually, so you weren't able to do a lot of things, like use namespaces to refer to an enum and its members, use namespaces to refer to the types here, in type position and in expression position. Call them, actually, the ones that take payloads, call them with the full name. You were only able to use the dot syntax, actually, the abbreviation. So there's all this stuff missing, and I just made a to-do list of missing things, all these, and I'm just cranking through it. So that is our context. So now I need context. So I'm going to run this and see what fails. And we're not compiling, so there's my context. 4757. And let's get to it. So yeah, I'm doing the generic one. So if I comment this out, I think we can run. I've gotten to this case. Val C opt of bool dot none equals opt dot none, and we're not passing a type. So the type is supposed to be inferred from context, and context in this case is coming right from here. And I put this. Did I? Unimplemented on generics pass type. That's not the one I'm seeing, but this is where I am right now. And I was going to do solving. This is the one with payloads. So let me go back and make the first one I do the one with a payload, because that my names are great. So this will be sum true. And the idea here is that we should see our message. That's we can do either of these, so I'll go ahead and test it both ways. Oh, then I guess this one should be. So first we won't specify and then we will. Both should pass. Well, not yet. We should see not unimplemented on generics pass the type. Oh, all the way to. So do these pass? Those pass. Really? Oh yeah, because I'm passing in the expected type. I see. This is the one that won't work. So these both work. Let's keep them. This is the one that won't work. Infer generic enum conster. So this is a special case, because what the compiler sees is the partial one. It checks that there is an expected enum in scope. So why can't I do that here? Yeah, because it does the. I'm having an idea to do what I'm already doing for these for this case. So what it's supposed to infer is this. So this is called, I'm calling it a non-enum variant. Am I? Yeah, with the dot. And I know this one doesn't take a payload, so is it parsed enum constructor? Yeah, it's this one. So what am I doing for parsed enum constructor? Okay, so I'm requiring that the expected type is an enum, not a generic. And in this case, yeah, the expected type is an enum, not a generic. So it just works. The problem would be, I guess, but if you're going to specify the type, you have to pass it. So, okay, so the problem is going to come up for us. Yeah, what I can do here, because in this case, I can just do what this is already doing. And I'm doing the expected type thing. So I introduced a function to try and, the other thing is trying to dry up all the places enum constructors happen because it's kind of a mess. Enum constructor. So here, is this actually, yep, already one? But it just wants the type ID. Oh man. Okay. It doesn't have its, they don't have their own type ID on them. So I actually lose it because I don't know if it was expected type or if I got a variant. So this probably needs to surface enum type ID, unfortunately. And if it's an enum, then that's expected type. Oh, that's funny. And then you're using that too. Okay. So we're gonna do this so that we don't shadow this, so that we have it. That's an ID. And then this becomes type ID to string expected type, which is now still an ID. And that one doesn't take. And what happens now is we don't need to get you, just enum type ID. And then we're gonna let enum type. These lookups are extremely cheap. Like it's just the cost, I think, of a bounds check. It's just a vector lookup. So we don't mind looking it up again to help out with borrow checking and stuff. So the expected type, yeah, we know we have one here, so that's great because this is the anonymous case. This case might be going away. I'm just trying to consolidate it to use the same code and see if it still works. So this is sort of indirectly making progress. No variant exists. Variant does not have a payload. Yeah. So I already have this. So yeah, so that's why I got lazy with the error messages too. Because this is way better. I was just calling it variant. So we'll do that. And it's still called E variant payload. So where's the case where it has one, but we didn't pass one? Here. No, where it doesn't have one, but we did pass one. Here. I wasn't erring there. This is if you pass one. It's kind of not much better to do it that way. And then instead of, yeah, so we have a span. Just getting this. Oh, it's not expected type. It's just enum type. E. Instead of returning here, we can do this. This is an alias for error. Well, for this, which is error. So error, and then okay with a none. And then what we can do is question mark this whole thing. So if there is a payload, you didn't pass one, say variant requires a payload. Oh, this is we do a let else. So instead of return, so we'll just do an if let then, and we'll do our success case here, and we'll do our failure case in here, and we won't do that, and we'll do okay. Some and it is if an else have incompatible, yeah. Really close, match arms, Y. You're an okay. And you're an error. I like leaving it. And Y. Cannot borrow because you variant. So variant.enum type ID, right? If we've done this, this is the variant. Which we can just define up here. This prevents us from borrowing it later if we need it without borrowing. And then this is our output type. So we type this a whole expression as if it's explicitly typed as a specific variant. So if it's typed as a sum, in the expected, then we'll type it as a sum. But if it's not, then we're going to type it as the enum itself, because that's often what you want. You're expecting just an option of t. So we'll give you an option of t instead of specifically a sum or a none of t. And this is variant name. We still have a borrow, right? Because we're evaluating an expression now. So that's why the other one was doing this, which is fine. So variant index, we'll just copy it. And then types.e. That has this benefit as well, which is nice. And then that's variant type ID. Okay, so this is now our single place where we're going to construct enum instances. And it handles payload and not payload. And it handles, whoops, the expected type problem as well. We'll make these blue. Okay. And now let's go back to our parsed enum constructor. That's where we were. And we're just going to call into our, this is what I did here. See, I borrowed the variant stuff and then I did this eval below. Same thing as above. So we don't need anything up to what we call this now. Right, so the variant name is, this is going to be e.tag, which is which is an old name. So this is the variant name. So we'll do e.variant name, enum type. Whoops, I cannot use my keyboard. Payload here, we always have one. So this is, it wants parsed expression ID. We don't even need that. And then that's that. And now it needs you. Okay. So I actually had the tests passing before this, which is nice. And I think they'll probably still pass. Oh, I need to go into here. Parse. No, we don't need that. Infer generic enum constant with payload. Okay, so we got down to a.k1. Let me split that off. Oh, that's why do all the tabs go over here? So I'm going to close others and I want to come over here. I'm going to open up the typer. Okay. And this was line 728. All right. Look how far we are indented. I can't even do a split. Also, this is a huge font size because it's what works for the recording. It's like my entire field of vision is the word infer. That's what it feels like. And then when I look at OBS, it looks like perfectly normal and pretty small. Kind of wild. I wonder if there's a way to make this smaller for me, but still large in the video. Okay, so the problem. Oh, right, it's this one. Sorry, it's been here all along. So if I fail instead, we'll see the line of code. Whoops. I need to return formatted fail. Maybe it should be fail F. Fail formatted, like printf. And then instead of fur, all right, I love fur, but we're gonna be, I like earth just as much. Okay. So we can see that it's on op.sum true. Right, it's because I didn't do so basically the anonymous one works because it requires that it's expecting an enum already. So I could do that here and then make it work, but the problem comes if BC. If this type were not specified, what that means is there's the instance of opt specialized on bool has not been created for us. So we have to make sure to create that, which is the act of specializing, which means we need to take some true and basically say, okay, what you actually want is some oh, it's the second BC. Ugh. Not right now, no. So, oh no. Can I do everything since the last compile? It's this one. Right, it's the non-anonymous one. So it's this here. If this weren't here, that's really the case that we need to, this is the reason why we need to handle this. We need to instantiate as if this were passed. And count on for generics 427 from context. So yeah, I think we're barking up the right tree. So I guess we should do the one where we pass it explicitly first. And that's this syntax, which is weird. I know it goes on the enum and the type, but then when you're constructing it, it's because it's like you're calling a function to make a sum versus you're talking about the type parameter. I think it actually makes sense. It's not just an accident. So let's try this one. Cannot infer generics for 24. Oh, okay. That's this one. Sorry. So this all has to do if type args is empty or not. So these are our two cases. So yeah, I'm finally caught up to where I am. And let's do it. So let's do the one where you pass the type args. All right, you passed them. So we don't need an expected type actually. So we're gonna use solve generic params. So I've done this before for functions, and that's all we're doing here. And I can reuse this machinery, but it's always fun when you reuse something for the first time, right? So the solved params, that's going to start off as an empty vec, right? And in this case, it's optional, so we only have one to solve. And what we'll do, so we have to call this, which will solve at most actually one param. It will solve it into this because it's used recursively. So it takes in your set of solved params, which is vec type param. So we'll do vec type param, where a type param is just a name and a type ID. The name's just for helpful. Usually the type ID is the thing that really matters here. And okay, past expr. That is the payload. And it needs to be typed already. So we'll do payload. I'm going to do because in either case I need, I kind of want to encode in one spot that the payload is the first arg. Payload. We'll just do a little borrow here. We'll just borrow it, and if we don't, a branch we don't use it, that's not gonna run, so that's gonna be free. And then this will read better. Okay, yeah, we had to map it. Arg. Value. Not the name. Okay, so that's our non-generic case. And in that one, we're actually checking the variant by name. So we can do that here before we go to specialize. Which actually means we can do it. I like this a lot. So variant name match. We don't have the enum. Shit. Okay, so we actually can't. That's fine, but we can do it here. So we're gonna say, we don't want this variant because we're just gonna, no, we do because that's the expected type. Yep. Yeah. So this will be a let else. Okay, so this generic has an inner type, and that is an actual enum. This generic just says, hey, I'm like a function that takes these type parameters, and then I will do the right-hand side. So to make that concrete, the generic is the guy that just says, I am optional of t, and my right-hand side is this. This is g.inner. G.inner is this enum. So this is the enum that we want to search for a variant matching the name we've used. And the variant name we've passed in case, it's actually some, SOME. So that's what we're gonna do. So this is just let enter enum. So that's just an ID, so we have to get it. And then we're gonna, well, we don't actually need to, we can as enum. We're not gonna expect enum because in this case, we haven't even confirmed that this is a generic for enum. So this is actually let sum. This is let sum enter enum. And this is where let else is really powerful because this just did a lot in one line. And it let me bail out without further indenting everything below. And it let me map, right, this option and bind a name and destructure. So matching let else is so good when paired with like good early returns. So this is going to be a return for fail. No, it's not even an enum. So the whole thing about this syntax is that if opt.sum is not actually a an enum that's in scope, then this is just going to be interpreted as a function call on, if there's a struct called opt with a method called sum that takes this, and we're just going to call that. So we're not going to fail if this doesn't match. We're just going to be like, oh, this is a real function call, not an enum constructor. So we just want to fall through. So I actually don't know how to fall through here. I don't think I can just like go to bottom or label, like jump out of this if, but that's what I want to do. The solution is to move this whole thing into a function that handles the enum constructor case, which it might be time to do. So that would be down here, findability implementation. I want that to stay because that's closely checked. So yeah, this is gonna be fun. Constructor fun call. And what it's going to say is it might not match. And so it's going to be a type of result of an option of a typed expr. So if the fun call it takes is actually an enum constructor, it's going to return the typed expr, and if it's not, it's going to return none. Obviously, if it fails, because the user wrote bad code is why it would fail, then we're going to return a failure. So what that means is everything we're doing, whoops, everything we're doing in here handle enum constructor fun call. So this is just going to be if let sum, and then we're going to question mark it. Whoops. Let sum enum conster return. Okay. Either left enum conster. See that? GS handle, and now what we can do is return if it doesn't match. So yeah, what I can do, I can make this now a let else return okay none, which lets me might have made a mess of this. It lets me unnest everything. We're gonna just bring that in by the same name. We're gonna need more stuff. Return okay. And we may not need to use early returns anymore for our success cases. We'll see. We'll see how we go here. So this lets us bail out, which is really nice. Enter enum variant by name. And the variant name is the fun call name. This outer name is a namespaced identifier, so it can be namespaced, and then the name is the name. So that's why we have name.name. We'll fix it. And then this is the same thing. We just didn't match. And now we have, this is like a branch we actually want. And then this is okay none. So this is what I'm talking about here. Oh, interesting. So this is all inside an if let. So if you don't even pass an argument, then we can't do this. LHS expr is opt. Yeah, okay. Because this is actually sum. This desugars to sum opt. True. Syntactically. So we're looking at the first arg for the enum name here. So if there is no first arg, then obviously we can't be in this case. So this will be a let sum. I don't like LHS Expert, but I was trying to remind myself that it's the thing on the left of the dot. And so now all of this code unnests again. And we'll deal with this to zoom out to figure out what's not aligning here. And and now it needs to be a variable, else we're also going to return okay none. There are a ton of conditions for this whole code path to even be relevant. But for us, I'll go ahead and indent this by hand for now. And then, yep, it also needs to be a type. So if this thing is not a type that's in scope, this whole case also doesn't apply. So this will also be let else return none. And now we have this match. Which might just have one too many, maybe? This one's fine. This one's fine. This is fine. So now we just have a match. We have 3 cases. And then that match is over. And then the function's over. Where is the syntax error? Where is the syntax error? Oh. Was it there? There it was. All right. So you see how we flattened this out? And now our successes don't need to be early returns. We're returning, this is the end. And it looks like this is terminal. Oh, but that's just a to-do. Okay, and then if it's not matching by name, that's okay none. Okay, we had an expected type. And we're back. Sorry for that. We'll zoom back in. Just needed a little context there to get the indentation fixed. Okay, so now sometimes you just need to do a little cleanup in the middle. This function has one job, and we don't really need to worry about where it was being called from, and we're able to return early without thinking about breaking what was going on in the larger function. So this definitely needs to be its own function. Okay. So the payload. So we need to know what type this is. So we need to type check this expression, which like really by type check, I just mean evaluate it. So we're gonna, well, we need a payload arg. This is the fun call case. So if we don't have one, yeah, we can just let that handle it here. But in this one, we really need the payload. So this will be we'll do passed payload. The one the user passed. And this will actually be a failure because we've matched all the cases. We found a variant. It's like we know they're calling op.sum, but they didn't. And they even did it with parens, but they didn't pass anything. So this will be that'll take some getting used to. Expected payload, I can even say. And we need to do the same here, actually. We need to confirm that the variant has a payload. So in this case, we need to decide if this is a user error or a bailout case. So it is matching some. Some doesn't take a payload, but they called this with parens. So yeah, this is fail. And this is variant. Requires a payload. And that's return. Fail. And now we do this. It's no longer optional. We know we have one. So we know they passed one. We know we have one. I mean, we have checked so many conditions to get here. This is the branchiest code. That's the whole point of a programming language, right? To cover all these possibilities with just a little bit of text. So I would hope a compiler is branchy. Otherwise, it's not helping you say things more succinctly than you could without it. Okay. So we need to run this guy. This is calling scope, unfortunately, in the expected type. Right, so what do I pass for the expected type here? It's going to be the variant type, but that's going to be a generic type. So the expected type here is going to be T, actually. No, it's going to be the payload type, which might not be T. So I need to be testing with, I need to be thinking about a generic enum. So let's do maybe a cons list, because that contains, it contains its argument. Nil. Cons. Right. It contains its argument. T list T. We got there. So the payload here is a struct. So when we come down here, you feel me? List.cons, what is the expected type when we run this expression? Well, it's struct with head T, tail list T. So the expected type is the generic, the variant, the generic variant payload. And then now we know what type the user passed in because we ran this. So this is going to be a passed expr type. It's going to be payload get type. That's the type of this expression. And now we're going to do a little solving where this is what you passed. And what we require is solve generic params takes and the type of the argument, which is variant payload. So the reason I have to hint with this is in case it won't be an exact match ever, because this thing expects generics and you can't have concrete values of the type that have the type of those type variables. But what you can have is what we could pass here. We're expecting a struct and we could pass, let's say, a reference to a struct. So by passing the expected type in, things like automatic dereferencing or other like smart behaviors can still happen to get to coerce the expression to a closer shape, so that the programming language has a goal of doing that for you when it just makes sense to do. A better example would be if this whole thing were an optional and you just pass in the struct, we would know to lift it to an optional, even though once we lift it to an optional, it doesn't exactly match the expected type because it's generic, not concrete. We can work around that basically. So we're going to run this one. This is exactly what I already do for generic function calls. It's just easier because I only have one argument, which is payload here, and I only have one param and one input. So now we got to solve. And it's worth mentioning there could be two params, and this thing will solve both of them. Let's say it was pair instead of list, and it was first and second. Then you'd better actually pass a first and second, and it should solve them both. If we have some time, I can jump into the solver. I've done a video on it. Check it out. Check out my video on the inferring generics. Pretty sure I figured it out live. Like the first video, what I do makes no sense, and then by the second, things might come together. I think that might be it. Maybe I just struggle, and then I figure it out offline, and then I made a video on the working version. But yeah, take a look. Okay. I'm not sure why this can fail. When do we fail? Oh, this is just one case, right? I was like, wow, it's so short. Double solving. Conflicting. Yeah, because this is where we would know. The other option would be to output conflicting data and then force on the caller to check. But so here's where I break down what it's doing. Like, hey, here's an example with a struct pair. Let's imagine the function is get first, which takes tu, it takes a pair tu, and it returns the pair of .a. Okay, get first. So the passed expression is pair int int. That's what you passed. What I need is a pair TU. So I have pair and int expand, A int, B int. I need ATBT, see? ATBU, sorry. And so now what I'll do is I'll recurse in and I'll see A int AT. Okay, T is int. And then I'll see B int BU. U is int. And then I solved T and U, even though there was only one argument. So our base case, the only case where we ever actually output anything is where what you passed is something and the argument type is just a naked type variable. That's like our base case where we're like, okay, it must be int. Like I expected T in this position and I got int. So T is definitely int, and then you work your way down. So it's basically just a matter of lining up the types. Here's a great example. So you passed me a reference to an int, and I'm expecting a reference to a t. Let me just go with those inner types. So that's going to be int and t, and then that's going to hit our base case. We'll be like, cool, I solved it. So we should expect as many params as the generic takes. And now we have this magic function that takes a generic type. So G. So we need the type of G. So I think it's up here. We called self.types.get on T. Why is it called T? Okay. Base type in scope. Base type in scope. Base type in scope. Passed params. This is what I'm passing. So this is the solved. What this function's doing, parsed ID. Ooh. Do you have an AST ID? Let me just look at fun call. Who has, you got a span. None of you, okay. The fun call args have expression IDs on them. Does our caller even have the AST ID of the fun call? No. But I could pass it. This is only called in one place. It's just an expression. What I'm going to do is not take a fun call. And I'm going to just get it myself. Get it myself. Expect. Do as fun call. So this is going to be expect fun call. And now we're going to generate that. This is a good time for AI. Generate this. Oh God. Oh no. Oh no. I'm so upset. Okay, so I set it up correctly. I was right here. We're here. That's the correct type. And I'm going to control enter. I'm in insert mode. So I'm all ready to go. And now you've done this, which I hate. Okay, so what if I delete this and I say generate expect fun call, please. Oh my God. We even lost the stub that we got. I'm trying to use the other one, but as soon as okay. Okay. I mean AI is changing the way we code. That would have taken me 10 seconds of typing and kept me in flow. But instead, I was able to lose 2 minutes of my time and get frustrated trying two different AI tools because I have FOMO about missing out on AI assisted coding. Fun call, expected type, calling scope. But the whole point is you need the AST ID. But I'll just pass it here. I'll pass the fun call and also the fun call ID. Whatever. Parsed expression ID. Okay, so back to instantiate generic type. What's going on here? Oh, it can't fail. Concrete type. We have a concrete type. What are you even returning? Okay, so all we've managed to do is well, we've managed to do quite a bit. We have made a copy of option for Boolean is what we've done. We're in this case, we've made a copy of option for Boolean. We've determined it needs to be Boolean. We've made that copy. So now what we need to do is make one of those. So this is our concrete type. So we're going to do let concrete enum. So what I'm realizing is we should call all of these generic. So now I'm really wishing I had just made these functions. If these were just represented as functions, then I wouldn't have to write any of this code. So if we put a function called sum inside the namespace option and made it intrinsic. Or internally implemented. But we let all the type checking and stuff happen this way. That's an idea. It would be kind of a cool experiment. Once we have a concrete type, so these two paths will unify. Once we know once we've solved the params, because this one takes type args, this one will still want to make the concrete type. So basically, once we've solved the params, these will become the same path. So we're actually going to do let solved type params. I've done solved or passed. We'll go vec type param. Oh, weird. I've been doing my infer path. Yeah, so this is the infer path. So basically, we're just going to return solved params. Now we're going to come down here. Fun call.type args. But we got to evaluate them. Oh, it's almost worse because we have to make sure that they actually work. If we solve them, we know they work. In this case, though, we're going to use solved or passed params. Why are you so unhappy now? If it's empty, do this. Otherwise, yeah, otherwise we return. So it should be fine. What's the matter? Okay, none. It's just saying mismatched types for this entire found unit. Equals if yeah. Oh, it crashed. Gotcha. Okay, now we're going to instantiate it with the ones we solved or the ones we passed. There could be a type checking step here. And not just any t will do because I'm going to do where t. I did it this way, right? I think I did it this way. Maybe I did it this way. But anyway, there can be constraints. Okay. We've got a concrete type, a concrete enum. If we don't have a variant by that name anymore, then we did something very wrong. So that's that. We're ready to make our enum constructor. The type ID no. Yes. Wait. Expected type. So if they're expecting, so here are the options. They could be expecting nothing, in which case we're going to produce opt of bool. they could be expecting opt of bool. So this will get type checked. Yeah, I guess we just need to check if they are actually expecting the variant that we just constructed because it already existed, which would be this case. So in which case we would have already done this making it concrete, and then this solving. I'll do it on this one, the one where we actually have to solve. The solving would be kind of wasted because we could have just used the expected type, but we have to have the code to solve anyway, so it's probably fine. So then we solve for bool, we instantiate opt for bool, then we go check, and it actually, when I do this instantiate, it'll actually see that we already have opt for bool, so we solved for t is bool. It'll say, oh, I already made an optional where t is bool. Here it is. So we'll get that back. And then if the expected type is also that, because someone already made it, then we'll do the thing we should do. Otherwise, we'll type it as the whole enum. We won't type it as the variant. So what that means is all we have to do is call our thing. With the concrete enum type ID, and if the expected type is the right one, then it's just going to work. Yep, only if it's the exact same one, which I think is what we want. We're going to do this. We're going to call it with question mark. This is going to be okay sum. And we just have to do this. Ah, we don't have to do it. Ah, and then we'll evaluate the payload again. Yeah, we did that outside. Yeah, we need that either way. Oops. Pass payload dot value. Yeah. So you might be asking why evaluate this again when we already evaluated it before. When we do it the first time, we're expecting a generic type, so we can't really do it all the way. We're just kind of doing it to learn its shape. And now that we fully know what type it should be, we can do it again and get a better result back out, because the type hinting and the coercion and stuff will all work out more strongly. And even we're gonna let variant name at the very top. Oh, not that far. How do I go back? I was GL to add one. GH? Oh, I lost them all. I was trying to multi-cursor so good. So it's funcall.name.name. We'll just do these ones. And then we'll do a variant name down here. Ah. Okay, so I only need the type IDs. Do you even need a vec? Yeah, you kind of do. I mean, you could take a slice. Could this be into? In specializations, wants vec. Ooh. Ugh. The hash map key is a vec. It should probably not be, right? It could be a boxed slice. We'll walk this back. Tool map. This is just an unnecessary copy. Type param. Because this thing only wants the type IDs. In this case, we always have a payload. This is called calling scope, and this is the fun calls span. It's funny that it lets this borrow last the whole time, even though I do eval expression. You know, fun call.span. How am I able to run this down at the very end when, oh, I guess nothing really takes, that takes mute self. Oh, we have other errors. I bet we're gonna get that borrow. Oh, this is kind of a bummer. I could have just put IDs. Ta-da! What's fun? Oh, that's fine. This takes mute self, so my borrow to fun call is gonna be invalidated. So I would rather check this after. And I can do this inside resolve. Ah. But it has to do with known value args, I see. Well, I can still do it right here. I don't think it's going to cause a huge problem if we, yeah, because we haven't looked at, yeah, we're not worried about known value args for the special cases in resolve, I don't think. Oh, that's funny. Taking the phone call by reference was better before because uh, we could have it and do mute self things. Interesting. Because then we use phone calls. We use the span way down below. Okay, now I look for the blue. Mm-hmm. These things all take in the whole thing. This is not something I wanted to change right now. I should probably just walk it back. Now here's the problem. I won't actually always have one of these because I invent um these sometimes. But when I invent them, I can pass the expression ID from the reason I'm inventing them, if that makes sense. So it might be okay. And I might as well give this the same treatment. I'm doing all this just so that I can attach the... I'm not gonna bother with it. I'm going to walk it all back and I'm gonna use a different parsed ID. So I'm not going to use this. I'm going to use the past payload value. I'm going to use that parsed expression ID. It's close enough for now. And this means that oh yeah, we don't need to do that. But that might be a nice improvement. And it's compiling. So all our work is in here. So resolve parsed function call, which is where we are, it doesn't have to return a function ID. It can bail and say this was a function, this was disguised as a function, but something else. So it's how I do return, as you can see here. It's also how I do some very special functions. And it's how I do these enum constructors now. Everything's a function call syntactically. Really should just be doing a Lisp. I should do a Lisp next. It'd be so fun. Okay, so what do I do now? I guess I run it. Did I finish? Yeah, this is the grand finale, right? Calling into our thing that just does the last mile. We have a real enum. Okay. I'm tempted to like quiet down our program a lot for now. And just keep this and this. We'll start with just the first one. Okay, yeah. What did I do wrong here? Out of curiosity. Hate my syntax. Okay. Right. I said I didn't want to deal with that yet. Whoops. We could deal with it. So the way we do that so how many params do we have, right? Feel me? I don't even need to know what the generic param is. Hmm. Funcall doesn't come from self. G.params does. Why? Because I guess I could modify G? Guess it's just a pointer. Yeah, okay. Can modify G in here. We have to check the constraints. That's it for that case. Boom, B is not defined. So it worked, type checked. Now, the way I did it, if I mismatch these, does it ever work? No, it's like, okay, that's cool, you passed whatever. And here's your payload. We never type check the payload against the concrete type. In fact, So in the case where we infer, this is what we should be doing, sorry. So in the case where we infer, it's going to be all good to go. It can't be wrong. But what I could do here is I could expect no, that will fail. Yeah, that's going to fail on the expected type because we do check those. But what we're never doing so it'll always match what I infer it to be, is my point, right? So it's just going to infer that it's int, so it's going to be fine. They can't mismatch. So it's only in the case where they passed them that it could, but it would still be nice to double check our solving. So we might as well check it. So we can do it here. And, oh, we could actually maybe do it inside here. Yeah, that might be cool. It's going to be as simple as a call to check types, which takes 2 type IDs. It's just the question of exactly where to apply it. That would be here then. So just because we passed in the expected type doesn't mean we've actually checked it or enforced it. This acts as a hint, and it's kind of inconsistently applied. Sometimes it will cause a failure, but it's considered just a hint. And I think I need to change that and make it a bit tighter because there's no scenario. Well, that's not actually true. There are scenarios. So more like we need to pass in a no check flag. Otherwise, but in the base case, we're always checking it. We get a nice message from our check types function. What's wrong with you? Okay, sorry, I can't finish the video where we spend hours and hours doing like strongly typed generics where we're passing on this int true. Like the entire point of solving these variables is that we can check them. So yeah, the irony is not lost on me that we were not able to check, but it's as simple as this. Like we just have to actually do the check. So there we go. We expected I64 because of what was passed here, but then you did a bool. So now we're good to go here where we can pass bool or we cannot. And let's go ahead and turn this into asserts just to like drive it home. So this is going to be assert. BC is sum true. This is pattern matching. This is single arm partial pattern matching using is. Okay. This should be typed. This should be typed as not the variant, but the enum. I think it's typed as the variant based on the expected type. I want to print the type of VC. Just to be really sure that, yeah. Opt.solve bool. That's yeah. It's the, oh, it's the first one that's failing. Huh. If I type you as opt bool, then it works, and then the second one fails. So we don't want this. We want this to be typed as opt bool by default, not sum. So we go into our handle. This has to do with the expected type that's getting passed in here somehow as what are our two cases here? Non-generic. So we're in generic, and we're using our expected type from the function call, and the expected type here is nothing at all. And so I might have introduced a bug here. So our output type, we're gonna get our expected type, and if we're expecting a variant, dun, 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 this should be enum type ID. That's the whole point of this. So the point is, if we're expecting something more specific, we'll type the term as the more specific thing. Otherwise, you want to type it as the more general thing so that you could put it in, for example, a list of optional booleans. Well, I guess you could also put a sum inside a list of optional booleans. B.has value should be false. Oh man, not that again. Oh no. Well, let's ignore that. Let's not worry about our list yet. I'm pretty confident this would work for multiple patterns. I mean, multiple. Let's do our pair real quick. We've been doing enums this whole time, so this would be an either. So let's do an either. Oh yeah, you gotta solve both. How does that work? So what I'm talking about here is, what do I infer for the type that I'm not making? How does Scala do it? It'd be kind of fun to figure out. Nothing. I don't have that. I don't have nothing. Oh, we don't have such things at home. Hmm. So nothing is an uninhabitable bottom type. The closest thing I have is never, but that's really like a control flow thing. It's not a bottom data type. Unit is different. Unit is like bool if it only had one case. So if it was always true. So you can always produce a value of type unit. You can never produce a value of type nothing. It has 0 types. It's inhabited by 0 values. Unit's inhabited by 1, bool by 2. Okay, well, we don't need to worry about that yet. Maybe a to-do item. What does Rust either do? Unknown. Either LR. Maybe I can read up on Rust's unknown type. Is this actually its type? Type annotations needed. So it's not. This is an LSP thing, right? I can say I don't know, but this doesn't fly, like long term, right? Scala officially more powerful than Rust, right? Do we need a nothing type? Well, am I going to call things there? I think so. That's what, I mean, we're inferring. Should I do my list? Let's do the list. We're going to risk it all. Oh. What was I thinking? I can't do. The naked recursion here is just not going to work. I might be able to do it as an optional. There's no way this works. Like that we just don't parse. Function not found. Okay. Right. I didn't do this one for payloadless. But I also don't think that I did passing the type yet. So we can't quite test this case yet because we haven't done all the cases. I wanted to do a simpler one that just has. This isn't even what I wanted because I want one that has 2. Well, let's just do either. No, what I really want is pair. But we've only been testing enums. So I'll make a contrived type. Which either is a pair or empty. Okay, contrive.stuff, contrive.empty. A is 42, B is hello. Okay, I ran into that case. because structs are kind of special. Man, I don't know how to just end a session on a win. Oh, wait, I actually do. Okay. Look, it works. We're able to infer the int type here, and we were also able to explicitly pass it and construct the correct instance of optional when we're passing payloads. So now we just need to support the syntax. So we did this one and this one. And I hope that the namespacing works. Yep, the namespacing works. So we did that one too. And we're inferring that one. Now we just need this one. Okay, there we go. That's how you end on a win. Checking off some to-dos, running a successful program. Thanks for watching.